Alright. Now we're going to learn about functions of function notations. Now, a function will always consist of x and y values, because this is how coordinates are being made. So, x is always going to be like in, what is it? X is like your plugging numbers in a function, and y is like the outcome. So this is so let's say sometimes it'll come into like a pattern or whatever the function is. This is your the values that you input. This is the result. Does that kind of make sense? So now these sets are called domains. These are called range. Okay, a set of x values is a domain. A set of y values is called a range. Okay? Now, in case if your math teacher likes to test you on vocabulary, then I'm just going to put this out here. I'm just going to make an equal sign. X is the independent variable. Yeah. Independent variable. The y value are the dependent variable. Reason being, like I said, independent variable because they're values that you just input, and the dependent variable are the values that are just outcomes or like as the result. So like what I'm saying is that's what a function is. This is the same thing. So if I say 3x plus 6, and I put in, I plug in, let me draw another x and y graph, and let's say these are the numbers that I want to put in. If I plug in 0, 3 times 0 is 0 plus 6, y is equal to 6. If I plug in 1, it's going to equal to 9. If I plug in 2, it's going to equal to 12. And so on, no matter how many variables I want to plug in. But see how these are the results when I plug in these numbers? That's why it's called a dependent variable. X is independent because they're chosen numbers that I want to plug in. And then the y are dependent depending on what function it is. That's what it is. Okay? Hopefully that kind of helps you easily memorize those vocabulary words, because it's not really that hard. So, okay. I'm just gonna erase this because that's just vocabulary. So, yeah, I already go through that. A function notation, it could be y, it could be f of x. These are what you call functions. It could be, linear. It could be quadratic. Just literally anything it's considered. Well, not always anything, but these are examples of functions. Function f of x, y. It doesn't matter what notation you use. They're literally both the same thing. Okay. To me, at least. Alright, so let's do an example. I tell you to evaluate f of 2 if f of x is equal to x squared plus 3. Let me write that 2 bigger. There you go. Now, evaluating f of 2, so that just means that, well, what's inside of the f? X, right? So that's like saying x, letting x equal to 2, evaluate meaning solve this, pretty much. Evaluating is plugging the number to x. So f of 2, that means that 2 is x. We literally just solve for this equation here. 2 squared is 4. plus 3 is what? 7. So f of 2 is equal, is equal to 7. That's all I asked. So when it's like f of a number, you plug in that number to x and you just solve what it equals. That's all you have to do. Okay? Should know you. Let's see. Okay. It's a different function. I just have to make sure. So we're still evaluating. Now let's say I tell you to evaluate 3 things. Evaluate -1, a, where a is a constant, not a variable. And then x plus h, where x is a variable, h is a constant. Okay? And the function for this one is 3x minus 4. Okay. I'm hoping this whiteboard does not drop. Okay, so I don't like whiteboards where it hangs itself because I care about whiteboards. Continuing, we plug in -1 because it's x, -1 minus 4. 3 times -1 is -3. Minus 4, -3 minus 4 is the same thing as -3. Changing that to plus, -4. 3 plus 4 is 7. So, but because they're both negative numbers, it's -7. So f of -1 is equal to -7. Okay? Let's solve for f of a. F of a, it's because it's a constant, but it's a letter constant, you just write 3a minus 4. Because, I mean, what else are you going to do? So, we don't know exactly what number that is. We just say, oh, a is a constant. And so whatever that number is, a could be any constant, so we just leave it like this. So this is equal to f of a. Okay? Not always, that's mainly because it's linear. But if it asks you like, let's say, if the function was like x squared plus 3 or, no, sorry, x plus 2 square or something, then you would have to simplify. So it would not be a plus 2 squared plus 3. You would actually have to simplify it further and you go from there. But let's keep going. We don't want to go off topic here. X plus h here. So now we're going to plug x plus h. We get 3 x plus h minus 4. You distribute, which is 3x plus 3h minus 4. And then you just leave it like that. Okay, this is equal to f x plus h. Just like that. Okay? Alright. Okay, that's it. Let's do another example. Oh crap. Okay. This time we're going to evaluate -1 again. But this time our function is going to be y equals x squared plus x. Okay. We have 2 babies. It's fucked up to only feed one, so let's feed both. So we plug in both. -1 squared is -1. Okay, -1 squared is equal to 1 plus -1. That's the same thing as 1 minus 1, which is equal to 0. So f of -1 is equal to 0. Just like that. Okay? Plugging it in. Now, I'm going to ask you a different question. And it's going to be with the same function here. Now, what if I asked you to solve f of x, when f of x is equal to 2. Now it says f of x equal to 2. Now what this means is now you're solving for x, which means that you're plugging this to y. Okay? So let's solve for the function x when the function is equal to 2. So function is equal to 2. Or you could, let's say, it's the same thing as this. You can still plug that in. They're both the same thing. So, just want to remind you of that. And then now we solve for x. If you remember your Algebra 2 stuff, you should know how to factor. So, they both have x's. So we could factor an x. X divided by x is, well, x squared divided by x is x. And then x divided by x is 1. So that's what you get. I did this incorrectly, did I? Okay, sorry, no. You only do that when this is 0. This is not 0, this is 2. My bad. Okay. Man. And I thought your teacher was teaching linear algebra. Okay, well, anyways. Ignore what I did. Sorry. That's only, you only do that if this is 0. This is not 0, this is a 2. You need 0 to the other side, and in order to do to have 0 on the other side, you're going to have to subtract 2 on the other side. So you're left off with this. Yeah, now in this case you can't do that. Well, you can factor, but not like how I factored by a distribution factor. No. This is a different case. So here, if you remember your Algebra 2, you factor out, well, there are some cases where it is factorable, like that. And then there are other cases where you have to use the quadratic formula. But I'm pretty sure, well, let's test this out to see if it's factorable. Because it's the easiest and fastest way to do it. So we have -2 here, the constant is -2. The constant here is 1, because 1 times x is x. We just don't write 1 on here, because no one does that. We just leave it as x. So that's a 1. Okay? So what you're looking for is this times this equals -2, but this times this, no, sorry, this plus this is equal to 1. So how do we find that out? Well, we know that 2 times 1 is equal to 2, okay? But it's not -2. So to make that negative, one of this number has to be negative. So this here, you are allowed to just test numbers. So negative 2 times 1 is negative 2, that's correct. But is negative 2 plus 1 equal to 1? No, it's not. That would be negative 1. So you cannot put a negative here. So that would not work. Now let's try that one. 2 times negative 1 is negative 2. Yes. 2 plus negative 1 is equal to 1. That is also correct. So this would be the case. So now that we have these two numbers here, we can write it like this. X plus 2, x minus 1. And so we're left off with this. Okay. Now, you have this is equal to 0. Now, you would see why we want this to equal to 0. If this is equal to 0, this whole thing is equal to 0. If this is equal to 0, this whole thing is equal to 0. So, this also tells you that you have two solutions of x, which is still a function. You can have two different x values that would equal the same y. You just can't have two different y values that equals the same x, because that would not be a function. So we could just say that x is equal to negative 2 or 1. Now, don't answer it right there. You're going to have to check, because there are certain conditions where it's called extraneous solutions. Extraneous solutions is where you have multiple solutions like that, but only one of them would actually work. So there are some times where you will have that sort of case, but I'm going to assume that you'll learn that later. In this case, well, we'll try testing it out right now. If I plug in negative 2 here, that's 4. Negative 2 squared is 4. Negative 2 here. 4 minus 2 is equal to 2, so that is correct. Let's plug in 1. 1 squared is 1 plus 1 is equal to 2, so that also works. So we can say that this x is equal to negative 2 and 1. So this does have two solutions. Okay? Alright. While I'm erasing this, I'm going to remind you again, functions can have x values with the same y value, but functions cannot have one x value with multiple y values. So here's what I mean. An x value, okay, an x value with the same y value. Let's say if you have like two of the same y values, it's still considered a function. Okay? It just won't be a one-to-one function. That's it. A one-to-one function is literally just one unique line or graph. And then we have that's a one-to-one function where each point, that's not really accurate, but you know what I mean, where each point is unique. Okay? And then we have that, where it is not a one-to-one function, but it's still considered a function, because if we do the vertical line test, you know, there's no this. Okay? That is not a function. Okay, so anything like that, where there's two points here and here for the same x value, that's not a function. A function cannot have that. Every x value has to have like a continuous, or not continuous, like a unique amount of, this is not diagonal enough. but you know what I mean. Okay. So, like I said, I'm going to write this again here. If you have, let's say, for some reason, you have two different y values for the same x, this is not a function. Okay? Not a function. You cannot have two different y values for the same x value, but you can have two different x values for the same y value. Okay? This is still considered a function. It's just not one-to-one function. That's it. It's just not a one-to-one function. But it is a function. That is not a function. Okay? Just to put that out there, assuming you will be tested on that. Okay. I'm just gonna say these definitions. A vertical line test, it just tells you that a vertical line test, what it detects is that if it's a function or not a function. This is obviously a function because there's no, every x value has one y value. Or every y value has one x value. Wait, yeah, one x value has one y value. Okay? So that's pretty much what the vertical line test is. Is to show if it's a function or not a function. Okay? If I, let's say for example, go like this, okay? Here this is not a function because when I go like this, there's way too many y values for one x value here. So this is not a function. So that's what that vertical line does, is to test if it's a function or not a function. Okay? Now a horizontal line test, it only detects whether if it's a one-to-one function or not a one-to-one function. For example, if I go like that, okay? If I do a vertical line test like this now, see here, now there's too many different x values for one y value, so this is not a one-to-one function. It is a function, just not one-to-one function, okay? This here, if I apply the horizontal line test, you see every point is unique, so this is a one-to-one function. So that's pretty much what that horizontal line test does. This is just to detect whether if it's a one-to-one or not a one-to-one function. That's it. Okay. Just those definitions. Okay. Okay, let's do some examples here. So here we're going to start simplifying and evaluating here. So let's go ahead, just for the sake of time, because this is a lot, let's just simplify and evaluate on the following: function of -1, function of, a negative function a. And that's it. I'm just going to leave it like that. Okay? And for this first problem, we have f of x equals 3x minus 4. Okay? So here, we plug in -1, we get 3 times -1, that's -3 minus 4. -3 minus 4, the same thing, like I said. That's -3 plus -4, this is -7. Okay? For negative f of a now, when you have negative a function, that means that, like an equation, we actually multiplied both sides by -1. So this means negative 3 of a minus 4 with that negative. And what that does, it makes this whole function negative, which is why there's a negative before the function, or -1 times the function. So this would be negative 3a plus 4. And that would be negative f of a. Okay? That's all what that negative is. Now, yes, that is different than having a function of negative a. So now, let's just gonna add this here. Just for this example. Negative a, that's entirely different than this, because when you plug in negative a here, this 4 doesn't get affected. So this is just negative 3a minus 4. Okay? This is for f of negative a. Okay? If it was negative function of a, then it would have been negative 3a plus 4. Okay, so they are entirely different. Alright? If it was negative a here, then that would have been positive. Okay? Oh, I erased with the wrong side. Dang it. Now my hand's all with markers. I'm going to take this out because that was just an example purpose. Okay. Next different function, we have y equals 1 minus x plus 7. What do you do here? It's, again, the same thing. You plug in -1, square root 1 minus -1 plus 7. 1 minus -1 is 2, because this is the same thing as 1 plus 2. So we get square root 2 plus 7. When you have a radical, this is called a radical, a number inside of the root, you just leave it like this. Okay, you can't really combine or do anything simplified, just leave it like that. And that's still considered a correct answer. Okay. Now, how about plugging in negative of f of a? So now that's like saying we plug in a negative function here. Okay? And then we've plugged in a 1 minus n plus 7. So this is equal, y is equal to negative times that. It's just this. This is, again, like you're multiplying -1. Like, it's just that we just don't write 1. It's just negative. So, 1 minus a, like that. -1 times 7 is minus 7. Or negative 7. So this would be the answer here, like this. Negative f of a. Okay? Next function, we have y equals negative 2x squared plus 7x minus 3. So here we plug in -1 again. Okay? And then we solve. Negative 1 squared is positive 1. So it's positive 1. Okay. This 7 times negative 1 is negative 7. So you write minus 7, minus 3. And then this is negative 2. So you're left off negative 2 minus negative 7, minus 3. Okay. Here we go left to right. Okay. Starting with the left side, negative 2 minus 7 is what? Negative 9, because this is the same thing as negative 2 plus negative 7. So this is negative 9 minus 3. Okay. Here, negative 9 minus 3, same thing as negative 9 plus negative 3. So that's negative 12. Okay. Oh boy. Time for a negative f of a. Alrighty, so I don't know why I erased that. Let's try it again. The camera died, so we sort of left off here. I think we're evaluating negative f of a, so because of that negative, we put the negative here. So we're going to multiply by negative 1, which is the same thing as dividing by negative 1. So multiplying or dividing by negative 1, you're just switching the signs of the integers. We already plugged in a, so that's easy enough. But here we just multiplying by negative 1 just by distributing, or I mean just by flipping the signs here. So here we get 2a squared minus 7a plus 3, just like that. And that should be your, this is f of a, negative f of a. That's it. Okay. Alright. Next function. F of x is equal to 3x minus 5 all over 2x plus 1. Okay, so again we're going to start plugging in negative 1 into this function. So we're going to go ahead. Substituting negative 1 to x. So 1. Okay. And then we just sort of evaluate negative 3. This is equal, I'm just going to write it right here. Divided by negative 2 plus 1. Negative 3 minus 5, that's negative 3 plus negative 5, so that's negative 8. And then negative 2 plus 1 is the same thing as 1 minus 2, which is negative 1. So this is actually positive 8, because a negative number divided by a negative number equals a positive number. Same goes with multiplication, negative times a negative equals a positive. So we left off 8. I mean, this is our answer, 8, for f of negative 1. So I'm just going to write it right here. So f of negative 1 is equal to 8. Okay. Now let's try negative f of a. So how do we do negative f of a on a rational function? So here, I like to evaluate first. So f of negative a is equal to negative 2x plus 1. Okay, so we substitute a x, so it's 3a minus 5 divided by 2a plus 1. So where does this negative go? Mainly, well, it could be multiplied by here, or it could be multiplied by the bottom side. It can't be multiplied by both sides, because that's canceling it out. So, but mainly we like to put it on the numerator, because that's just, it's just less complicated when we multiply by the numerator, because we always like leaving the denominator alone. So, for here, this negative is going to be only flip the signs of this top side, and that's it, okay? It should not affect the bottom. So we should actually get negative 3a plus 5 all over 2a plus 1. Just like that. Okay? Alright. Let's do another problem. We're going to evaluate f of negative 1, and we want to solve f of x equal to 4. And the function that we're going to use for this problem is the square root of x plus 2. Alrighty. So let's start with evaluating negative 1 first. So this one should be easy, you just plug it in. Negative 1 plus 2. And 2 minus 1 is equal to 1. So you pretty much get the square root of 1, which is equal to 1. Okay? Now, how do we solve for 4? Well, we plug in 4 equals square root of x plus 2. Now we have an equation. So solve for x. Because this is a square root, we're going to square both sides. For how I like to do it, I just say like the square root goes to the other side, meaning you square it. But just for how you guys learn it, we're going to square both sides. So 4 squared, 16. And then if we square this side, I'm just going to write this here too. So if we square both sides, squaring squaring the square root cancels it out. So it gets rid of that root, but it also has to square the other side. So now 4 squared, 16. Now we could easily solve for x. You just subtract 2 to the other side and you should end up 14 equals x. So if you plug in 14 here, you should get 4. That's just pretty much what it means. So yeah, that's how you solve that. Very easy. Okay, so now we're going to start going into finding domains just by looking at the equation. So this one, it's going to be a lot, I'm going to have to provide a lot of explanation to this, because it does come into a pattern. So when you have a function equals, let's say, a polynomial. So a polynomial is just like a function with just numbers plus or minus a variable to the power of, like, functions like this, or like this. Like all of these, like in a straight line, you know, These are polynomials. So when you have a function that's a polynomial, it's always going to be infinity to infinity, negative infinity to infinity. So this would be your domain right here. The only time, well, just be very careful. Sometimes if your teacher is a dick, they'll put exponents here, like that. So now that's not a polynomial, because when you have a fraction as an exponent, this is meaning 6 minus 3 square root of x cubed. That's not a polynomial, because now you have roots, and that's something different. So make sure that the polynomial does not have any fraction in the exponents. But for this case, because this is a polynomial, it's very easy that the domain is just negative infinity to infinity. Okay? Alright. If it's just like x cubed or just a constant, that works too. That's also still called a polynomial, but specifically if we were trying to say what kind of polynomial it is, we say monomial, and these both are also the same domain as a polynomial, negative infinity to infinity. So just a monomial by itself, like a variable or just a constant, it's the same thing like polynomials, it's just negative infinity to infinity as a domain. Okay? Now, speaking of roots, what if we do have one? Okay? Now we're going to have to be a little specific here. So, square roots, they cannot be negative. Okay? You cannot have a negative number in a square root. So, to sort of know that, to find the domain of this function, we have to know, because this is inside of the square root, we're going to only focus on the inside of the square root. What's inside of the square root? X minus 2. Okay? We're going to set that to 0. So x minus 2 is 0. What does x have to equal to make it 0? X is equal to 2. Okay? Now, because x is on the left side, if it goes any lower than 2, it's going to become a negative number. So we know that for our domain, I'll write it right here. Our domain can only be exactly at 2, but no less than 2. Otherwise, it will be undefined. Or, well, it wouldn't be undefined, it will be a complex number. But in graph or on your calculator, it'll say like non-real or undefined, whatever your calculator says. You cannot have a negative number in the square root. So the domain would just be at 2. Brackets means exactly at 2, because the reason why I put a bracket here is because you can plug in 2. Because when you plug in 2, it's just 0, and that's fine. So we put a bracket, but it cannot be any lower than 2. So that's why we stop it right there. Okay? All the way to, and then whatever is a big number, it could be any big number, whatever, it won't get to negative. So we could just put infinity here. So that would be our domain for this function. Okay? Alright. How about 3 minus the square root of 6 minus x2? 6 minus 2x. Okay? Now this is even more specific. So again, we're going to only focus on inside the square root, and we're going to need to set that to 0. Okay? and then you solve for x. This is 6 equals 2x. We add 2x to the other side, and then here we're going to divide by 2, just to make this look easier for you. X is equal to 3 when we divide both sides by 2. So this, well, because this is on the right side, now we're going to have to like sort of test things now. So because x is equal to 3, when x equals to 3, it's going to be 0. Can you be larger than 3 or less than 3? And to find that out, you just test some numbers. So for example, just let's say 4. If I try 4, 2 times 4 is 8, 6 minus 8, that's going to give me a negative number. So that tells me that you cannot go more than 3. So, because you can't go more than 3, it's going to be like that. The bracket on the right side, because that's where you increase, but you cannot get any bigger than 3, so it stops right there. And it's a bracket because you can plug in 3. Exactly, because it'll just be 0 and that's fine. Okay? Now how about the other side? Can you go negative? Yes, you can. And here's why. When you plug in any negative number, no matter how negative the big negative number it is, 6 minus, or a number minus a negative number is going to be positive. Because that's saying 6 minus, and then whatever that number it is, it's always going to be positive. So that means that you can go infinitely, or you can keep, it could be any negative number. That's how the domain is going to be looking like. So that's the domain for this function. Okay? Okay. Alrighty, now let's do, let me do this first of all, okay? Now you have a rational function. So when you have a rational function, one of the important things you have to look at is at the denominator. Because just like square roots, well, not like square roots, you know how like square roots, when it has a square root, you have to focus on the square root. Now this one, when you have a rational function, you have to focus on the denominator. The denominator is at the bottom part, and at the bottom part, it cannot be 0, because 5 divided, or a number divided by 0 is undefined. So you cannot have a 0 here. So to do that, where does x become when it's 0? Just do the same thing like the square root. X minus 3 is 0. X is equal to 3. So this means that x cannot be 3. Okay? So our domain, I'll write it right here. It could be any number. So this just means that it could be any number except 3. Because that's the only number you cannot have at the denominator is 0. Never 0 at the denominator. So you could separate it like this. Negative infinity to 3. Now, you cannot plug in 3. Okay? Because that's gonna cause it to be 0. So instead of putting a bracket, we put parentheses. What this means is that it could be any number close to 3. So it could be like 2.9999999 something. Plug it here, and it won't be 0. You see what I mean? So anything close to 3, that's what that parentheses mean. Okay? And then, I'm going to erase this because you already know what x cannot be. Okay, so you write that, and then you write a u to that just gives you a definition that it's a set of intervals. So 3u, then you write 3 again, because you could also be close to 3 at the positive side. So meaning I could go like 3, 0, 0, 0, 0, 0, 0, whatever, and then there's like a 1 at the end. Plug that in, it's still gonna be like, it's not gonna be 0, but it will be like 0.000000001, like a very small tiny decimal, and it won't be 0. So close to 3 to infinity. So this right here is our domain for this function. Okay? Now, I'll go ahead and put up the original problem. What if it's a square root now? Okay, so here, so what I like to do first is do the square roots first. And the reason why I want to do the square roots first is because the square root is inside, more inside first, and then there's a denominator. So we know that the square root, x minus 3, we already done this, x is equal to 3. So we know that the square root cannot be, x cannot be lower than 3. Otherwise it will be a negative number. So I'm just going to put a 3 right here. Okay. When you write that, make sure it's in pencil so that you can erase it. And then, now that we know that, you can also not plug in 3. So now we're going to go ahead and think of this like solving the denominator. See, this is the same thing. If you square both sides, 0 is still 0. X is still equal to 3. So now we know that x cannot be 3, because that would make the denominator 0. So we could erase this and put parentheses. Okay? And then it could be any big number, infinity. That's our domain. Okay? So it cannot be 3, and it cannot be any number lower than 3. So this is our domain for this function. Okay. Alright, this one's a little tricky. Okay, so here you're going to have to be doing a lot of testing here. So you can choose which first you want to go. I'm going to do top first. 6 minus x equals to 0. 6, if I put x to the other side, x is equal to 6. So because it's at the right side, x cannot be greater than 6. Or, yeah, x can be bigger than 6. That's only because it's at the right side. So if it goes negative or lower, it'll turn that minus to a positive, because 6 minus, or a number minus a negative number is a positive number. So we know that you can plug in 6, because it'll just be 0, so that's okay. It just can't be bigger than 6. So we'll put that as a bracket. Okay? Alright, now let's do the square root of x plus 5. Okay. Here we're kind of doing the root and the denominator at the same time. So x plus 5 equal to 0. Subtract 5 to the other side, and we get x equals negative 5. So because it's also at the denominator, we know that x cannot be negative 5. and x cannot be anything lower. It cannot be lower than -6. So we know for sure that we can't, because if you have x lower than -5, you're going to have a negative number in the square root. So like if you plug in -6, it's going to have a negative number in the square root, which you cannot have. So, and you can't have -5 because -5 plus 5 is a 0, and you have a 0 in the denominator, and that's not good. So instead of putting a bracket, you put parentheses, -5. Okay? So this means that this function, it cannot go infinite. So there's no infinity in this interval, so this is all we have as a domain for this function. So this is the domain for this function. Okay? Alright. Okay. Determine if it's a function. So, let me erase that part. So how do you know, when you're given an equation, how do you know if it's a function or not a function? I'll just write the first problem here. Okay, so how do we know if this is a function or not? Well, to have a function, we're going to solve for y. So when we solve for y, we should only end up with one solution. If you have two solutions, it is not a function. So we're going to go ahead and solve for y. We're going to subtract 5x to the other side. Or, put it like this. Okay? And then we're going to subtract, not subtract, divide 2 on both sides. And we should get 5 over 2 x plus 10 divided by 2 is 5. Okay, so we divide 2 by both sides. And this is our, this is what y equals. So we have one solution, so this means that this is a function. So it is a function. Because it only has one solution. Okay. What about this one? X equals 3y plus 5, 7y minus 1. Okay, well, this one, because, imagine this is all together. Okay? So you could actually multiply the other side. So pretty much what you're doing is you're multiplying 7y minus 1, 7y minus 1 to both sides. Yes, you can do that. Even if it's like a function, you could do that to both sides. Because, it is equal to each other. So, we get 7y minus 1x equal 3y plus 5. These two will cancel each other out. Okay? Because 7y minus 1 divided by 7y minus 1, because they're both the same thing, it's just going to equal to 1. So we'll be left off as this. Okay? Now, this one's a little kind of scary. Okay, so we're continuing. So, this is a little scary, but just watch carefully. So we're going to distribute x. So if we do x times 7y, 7xy, x times -1 is negative x, equals 3y plus 5. Okay? Now, because we're solving for y, we need all the y's on one side and all the monomials that aren't y to the other side. So, meaning I need this y to be here, and I need this x to like get the hell out of that other side. So, I'm gonna do this all at once. So I'm gonna subtract here, and then I'm gonna add this to the other side. Okay. Now that we have both y's in one side, you can factor it. So you can factor the y out, which you let y like that. Divide y, 7x. Divide y here, you get -3. Just like that. Okay? Now, because y is by itself, this whole thing right here, divide it to the other side. So it's like this, but opposite. So if I show it to you, you're dividing 7x minus 3, 7x minus 3. Okay? Do I have room here? I guess I do. Do I? Yes, I do. I can't tell. My camera's very far away. So I'm going to write it right here. So y is equal to x plus 5 all over 7x minus 3. Is it one solution or two solution? One solution. So because that's our only solution for y, that is a function, surprisingly. Okay, so we're going to go ahead and do another example. Okay. Okay, x is equal to the square root of 1 minus y squared. Okay, so again we're going to solve for y. So to get rid of this x, the square root, we have to square both sides. So if we square this side, it will be x squared. If we square this side, it gets rid of the square root, so we'll be left off with 1 minus y squared. Okay. I'm gonna go ahead and I'm gonna get that y squared to the other side. So I'm gonna add y squared to the other side. So yeah, and then I'm gonna subtract x squared to the other side. So we'll end up like that. Now here, do not forget what I'm about to do. So I'm gonna, because we want a y by itself and it's squared, we're gonna square root it both sides. So when you square root both sides, this becomes y equals, now it's a plus or minus square root of 1 minus x squared. Now why do we have a plus or minus? Because here's why. When we have a number, let's say c, for a constant. C could be any constant, whatever number it is. Let's say c. C, if we square it, it's going to equal c squared, right? Okay. Now, what if that c was negative? If we square negative c, it's still going to equal to c squared as well. So whatever that inside is, plus or minus c squared is still going to equal to c squared. Okay? Now if I square root both sides, now you have two solutions. So this is meaning that y is equal to the positive of 1 minus x squared or negative 1 minus x squared. So that's two solutions. Okay? Square both sides, they're going to end up with the same answer. So that's why we always put plus or minus. So because we have two solutions, this function right here, well, it's not a function. So this is not a function because it has more than one solution. Okay? Alright. X equals y squared. Okay. Solve, well, this is pretty obvious. Square root both sides. I'm going to rearrange this. And then when we square root both sides, we get y equals plus or minus square root of x. And because this is the same thing as or negative root x, that's two solutions. So this is not a function. Okay? Okay. What about this one? Well, y is already itself. So I mean, this is our answer. So we don't have to really do anything. And because this is our answer, and how many answers do we have? Well, it's only showing this one, right? Yeah, it doesn't have that plus or minus. So because, I mean, it's one solution, and they only gave us one solution, we can say that this is a function. Okay? So that is a function. Now, if it gave us this, that would not be a function. Alright? But because it didn't have that minus or plus or minus sign, it only gave us this, it is a function. Okay? I don't want to dirty the side that I'm holding with. Okay. I'm just checking on the battery because that was very bad. Alright, so we're going to do the domain thing again, except with more cases now. So we're going back to finding the domain of a function. Alright. So, how do we find the domain of this function here? Now, what's so different about this is that it has an x square inside of the square root. So, like I said, we're going to do this again. We're going to do the same approach. We're going to let x squared plus 4 equals 0. Okay. What teacher gave you this is a bitch, because this is going to end up negative 4, and you cannot square root that, because that's a negative number. So, we're going to erase all of this again. Now, what I just showed you is that what I just showed you is You know what, I shouldn't have erased that. I'll put this back up. Because, x cannot be a negative number. Because, this is undefined, right? So, when you square a negative number, it's always going to be positive. So what I just showed you here is that this here, you could put in any number, even a negative number. If you put in a negative number here, it's having it squared is going to come out to be positive, and you're still going to end up with a positive number inside the square root. So because we have this very nice this square here, this will never get negative. Does that make sense? So when you end up with this, x squared equals a negative number, it just means that whatever is inside that square root can never be a negative number. So you can plug in any number, whatever. This domain will always be negative infinity to infinity. Okay? Alright. You don't even have to do this. I only just to show that, just to easily explain it. But you can just see here that, it's an x squared. If you plug in a negative number, it's going to come out positive, and it'll always be a positive in the inside, which is good. So this could be negative infinity to infinity. So this is the domain for this function. Okay. Now, what if it's a cube root? Okay, now this is a whole different story. So, when we have, let me just write this, okay? If n is an even number, okay? If it's an even number, the function cannot be, or whatever's inside here, cannot be a negative number. Okay? However, if n is an odd number, okay, this function, or whatever is inside here, can have a negative number. So yes, you can have a negative number if there's an odd number root. Okay? Let me explain why. So, I can prove this to you. Just for basic matter, let's start with -1. Okay? The reason why -1 squared is positive is because when you have a negative times a negative, it equals to positive. Okay? Now what if I have an odd number as an exponent? Well, I'm going to rewrite it like that. That's what this equals. So when I do a negative times negative, that's a positive. But I still have that negative there. So that makes it -1. So this is equal to -1. Which is why if it's an odd number, we can have a negative number inside that cube root, or an odd root number. Odd number root, whatever it's called. But as long as that number is odd, you can have a negative inside here. So it's not a fraction function or a rational function. So it seems like there's no discontinuity in any of this function. So it's not at the bottom, it's not a denominator, and because it's a cube root, it's safe to say that this is negative infinity to infinity. So you don't have to do like a checking. You don't have, this is unnecessary. This is pointless because we already know that you can have a negative number inside an odd number root. Okay. So this is our domain for that function. Alright? Okay. Here, a very easy one. So we just look at the denominator, we just set it to 0, x minus 0, x is equal to 6, when we put it to the other side. And so x cannot be 6, and that's it. So we could say our domain for this function, we could have any number closer to 6 is fine, and whatever at the other side as well, closer to 6 to infinity. You just can't have 6, or you just can't plug in 6, otherwise it would be undefined. So this would be our domain for this function. Okay. Let's go again. Next function. 3x plus 1, 4x plus 2. Now again, we're only just worrying about this bottom here. Okay? So solve for 0. Okay? Take that to the other side, subtract it to the other side. Divide 4 on both sides, you'll end up with a half, because 2 divided by 4, that's a half. So, or this, and then you could simplify it to like that. But I'm just going to simplify it just for now. I think this is still correct, but I mean, there are some math professors who have OCD, so they want to simplify it, so I'm just very used to that. Yeah. So x equals negative half. This means that x cannot equal negative half, because if you plug in negative half, you'll have a 0 in the denominator. So, now that we know that, it cannot be negative a half. We can go ahead and simply write our domain, negative infinity to negative 1/2. You set negative half to infinity. That is our domain for that function. Okay. Okay. Oh, I forgot to erase that function. Alright. X plus 4 divided by x minus 4. Alright, so here we got some things that we need to know. So I'm just going to start with I always start from the top. That's just me. X plus 4 equal to 0. X is equal to negative 4 when we subtract both sides. So, and because x is on the left side, we know that x cannot be less than negative 4. Yeah, x cannot be less than negative 4, because if x is less than negative 4, for example negative 5, plug in negative 5, you end up with a negative number in the square root, which you cannot have. So we cannot have any number less than negative 4. Sorry, that's not parentheses. Bracket. Because you can plug in negative 4. It is okay to plug in negative 4 because it will just be 0 and that's okay. So a bracket for a negative 4. Alright? Here, sorry. Now we're going to solve for that denominator. X minus 4 is equal to 0. In this case, when we add 4 on both sides, we get x equal 4. Okay? So, in this denominator, x cannot be 4. Otherwise, you'll end up having a 0 in the denominator. So you can have anywhere close to 4, but you cannot plug in 4. So, parentheses, a set of 4, and then you can have x can be anywhere greater than, or whatever, as long as it's not 4. So, infinity here, and that's your domain for that function. Okay? And that's pretty much it. I forgot to mention in the last video, I would put a study guide, or I made more practice problems so that you can study for your pre-calc class. So I'll put it in the I'll probably put it in the description or comments. I'll put it in the I'll most likely put it in the description, but sometimes I'll put it in the comments, sometimes I'll put it in the description. Just check both ways, because I won't remember what I said after finishing this video. So hopefully that helps. And I'll see you guys in the other next videos.